Okay, welcome to our RoboPro introduction. This is going to get you started hopefully with RoboPro, teach you a few tips and tricks about it, and we'll go from there. So we have our same basic setup on our interface that we had when we left, where we have a photocell hooked into AX, we have a digital switch plugged into I1, and we have a motor plugged into M1. I'm now going to hit New to create a new program. This right here is my workspace, and I can drag and drop my icons from over here. And again, if you look at the PowerPoints that are in the curriculum, those should be really easy to follow along with. And then you can also look at the activities and that are in the curriculum and use those. They're great for students to kind of go through as tutorials on their own, but these videos might be a good supplement resource for you on that. The first thing I always need to do is start my program. And you can actually have multiple starts within your program. They run simultaneously, so if you wanted multiple tasks to be running at the same time, that's kind of nice. That's more advanced, but for right now we're just going to use one in here. I just want to program simply to start a motor and then stop it. So here's my motor output, and it's called motor output. However, it's used for all of our outputs. So it's used for lamps, it's used for electromagnets, it's used for solenoids. They're all considered these motor outputs. And then if I just stopped, oh, by the way, it will auto connect your arrows if you put them close. So if they're far away, you have to click, so you can see that the hand changes to like a little tool where you'd click and then click down here where it connects. The easier way is to just drag it up until it auto connects. Just a couple reminders that you want to make sure that your environment is in the RoboIF environment to begin with. Check your COM USB and then do your test. I've already done that, so I didn't go back and redo it. But you want to do that. You want your students to do that every time they log in and start RoboPro. Is check those three things, make sure everything is good with that. If I hit start, you can actually hear the motor run for just a brief moment, and then it says the program has been terminated, because essentially that's what it does. And sometimes the motor might not even start, depending on your connection speed. If you're using serial or USB, sometimes the serial, if it's connected via serial port, the time that it takes to send the signal and then to stop the program is much too fast. So it doesn't actually start the motor at all. And students are wondering, well, why doesn't it start? You told it to start. Well, you told it to start, but then you told it to end the program immediately. So if I wanted this motor to be on for, let's say, 3 seconds, again, I'm just clicking and then deleting. I'll move this down, and I need to include a time delay in here. And if I wanted 3 seconds, I could just, drag 3 of these in, but what if it was 20 seconds? Am I going to need to drag 20 of these in? Well, no, there's an easier way. Programmers are smart guys, so they don't want to do that to you. If you right click on any of these icons, it pulls up a window that you can usually change a lot of the parameters that are inside there. So if I wanted a 3-second delay, I can just put that in. You can change it to minutes or hours if you want as well. And then I always teach my students that if I start a motor and I want it to stop, I need to tell it to stop. So again, this is plugged into M1. Right now this is the symbol for clockwise. You can see the green arrow is rotating clockwise. I'm going to right click on it, and this pulls up a dialog window where again I can then change what port it's plugged into. It's still plugged into M1. There are extension modules that you can actually add on to these. We don't have it, we just have the interface. That's what the IF1 means, interface 1. We can change what type of output it is. So if we wanted a lamp or a buzzer or electromagnet, which we've talked about a little bit earlier, you can change the image that would be shown here. We can change the action, so here I want this one to stop. I can also change the speed. So if I wanted to be moving clockwise but not at full speed, and I wanted to be at, like, let's say half speed, then I could change that to 4 instead. And you can see the V, the velocity, is 4 now on that. And now if I hit start, you can hear and see that it runs for 3 seconds and then stops the motor. So this is what you're going to be doing. And then you can give your students like different examples, and this is where you can differentiate instruction. This is kind of why I love this particular unit. Is you're going to have some kids that get this and they're snappy. They understand logic. They can go through flow charts, and you can give them harder problems to tackle. In this case, let's say that we wanted to start and go clockwise for 3 seconds, and then stop for 2 seconds, and then reverse for 3 seconds. So here I'm going to go counterclockwise. And you can also change the speeds on these so that they go like forward at half speed. You can go reverse at full speed. Whatever you want. That's kind of, as a teacher, you can kind of make up these little problems for them and whatnot. And again, the last thing I always want to see is if I want to stop at the end, I need to have a stop icon at the end. And then I can run the program and 2 second stop, and then reverse at full speed for 3, stop. So these are the kind of things that you're going to be doing, and again, it's pretty intuitive. It's drag and drop. A couple things that students that I've noticed, let's say they take out an object and now they want to reconnect, and they kind of do this kind of stuff. You actually have to delete the arrows and make sure they reconnect. Another thing that happens is sometimes the tool gets funky when they start doing this, and they can't get it to stop. Like they can't get it to ground on anything. Well, if you double click, it'll then drop it. Click on it anywhere you want and then hit delete to get rid of it. I usually let it auto build, so again you can drag the item up and then drop it when it auto connects. I feel that that's the easiest. Another thing is you want to make sure that your students have good flow to their design. You don't want to see a flow chart that looks like this in nature. This is too hard to read, so I make it very linear, very structured. So I tell them that I won't even help them troubleshoot unless it's organized neatly. The other thing that I want them to do is I also want them to comment their code, and to do that you can click on these little drawing functions, and you can have them say what, like for example, what is M1? Well, M1 might be the elevator motor. And then I want them to define a few parameters. Maybe CW is up, and CCW would then be down. So these would be good things for them to add into their code or into their program, so that when you're going around and troubleshooting, you know what M1 is on their interface and what it's connected to on their build. So it makes it a lot easier for you. So I make my students have that. If I don't see little comments within their code, I won't look at it. It's just too difficult to troubleshoot. You'll waste too much time on students that haven't done a proper job of thinking through what the actual error is. So it's just removes some headache from you as a teacher to go through and make sure that they're doing those things correctly. If you need to, you can actually zoom out so you can see more of the program, or you could zoom in. Also, if they're doing something that's linear like this, I usually have them bring this up to the next level and then continue on another row so I can see it. So I don't have to zoom out or scroll down. I want to be able to see their entire program, typically on one screen if I can, for troubleshooting purposes. But those are things that you can do and have them do. The next thing I want to talk about is some branch functions, and then analogs, and then that's kind of it. So whenever we have sensors are designed to make decisions for the system. So we have two different branches here. If you notice, you can see that there's one input, and then there's two ways that we can go depending on the condition of that sensor. The same thing here with your analog branch. You have an input at the top, and then it has two options to choose from depending on some inequality typically that's within there. So we'll first do a switch. So let's say, for example, that I want a motor to start when the switch is pressed. So the first thing I need to do is check the condition of the sensor. So if it's pressed, the motor is going to start, so that would be a 1 value. Remember, not pressed is 0. And if it's not pressed, I want it to wait or keep checking the sensor. So if you notice here, this loops back and it continues to check the sensor until it's pressed. And when it's pressed, we can then turn the motor on for a certain amount of time. You can stop the motor, and then we can end the program. And again, this would be a simple branch program. And if you notice, I'll start it. Again, it's going to sit there, and you notice that the red is kind of nice. It tells you where you're at in your program. It's just sitting here waiting until I click the switch. You'll hear the click, and then the motor will start. Okay, so things like that, pretty simple. I can actually remove this, and then I can plug in the analog branch function instead. So now I'm going to use my photo cell. So I'm going to open the test interface window just to get a value. So right now there's a value of 154 for that, and if I put my hand over it, it jumps to 1023. So I'm just going to say if it gets above 500, I'm going to pick a number that's kind of in between those as a threshold. So anything below 500, it's not blocked. As soon as I get above 500, we're going to say that it's blocked. So we're going to say that it's going to sit there so if the value gets greater than 500. So let's look at how this works. So AX currently, when my hand is not over it, is 150. Is 150 greater than 500? Well, the answer is no. So it then continues to check that sensor. And as long as that sensor value is less than 500, it'll then stay in this little loop right here. As soon as I cover it, let's pick a value, let's say 1,000. Is 1,000 greater than 500? Yes. It then moves on in the program, and that's what we should see. So I'm going to hit start. It's waiting here, and if I cover it up, it then moves on in the program. So these are things that are students will grasp very easily on how to do that with branches. It's great. You can have them start a motor with one switch and stop it with another. Again, you just make sure that you right-click on this so you can pull open the dialog. You can pick whatever input it's in. Again, these are digital, so there's my photo transistor, and you can see that it changes the picture to that. You can also swap the 1 and 0 branches. So if you notice here, the 1 is coming out the bottom and the 0 out the side. Sometimes you might want to do it this way, depending on which way you want your flow to go in your chart. So there's some advantages to being able to switch those pretty quickly instead of rewriting equations. If I wanted to do the other way, where I'm going to cover it first and then remove my hand to turn on the motor. All I have to do is switch those branches. Now if I hit start, it says this isn't connected, so I'll delete that out of there. So now my hand's currently covering it, so the value is greater than 500. It stays within the loop right here, and then when I uncover it, it moves on. So there are some nice little things that tricks that you can do with that. I'll do another video, a little shorter video here on some of the more advanced features in here, but hopefully that gets you started with programming.